Raise your hand if you're like me. When I was in school, I made the mistake thinking this derivative equals 1. And that's a whole kind of wrong. And I'm going to show you in this video why that's not the right answer here, so you can understand how to actually get the right answer for the derivative of the absolute value of x. Let's look at the graph of that function. Do you remember that it looks like this v, and you have this cusp here at the origin? Now, check this out. There's actually two things going on with this graph, depending on if you look to the left of the origin or to the right. It's almost like we have two separate lines that are mirrored, and they're just being stitched together in a single function. Not only that, but if you think the answer to the derivative is this 1, which is a constant, then wouldn't the graph here be very clear that no matter where you look at the slope, especially if you're on the negative side of the y-axis here, wouldn't that look like a slope that is a constant value? So the problem here with that answer is we're not really understanding the absolute value function to begin with. So what I want to actually do to find this derivative properly is I want you to actually reframe your thinking around the absolute value function as if it's a piecewise function, where to the right of the origin, the absolute value isn't doing anything because whatever x is, the absolute value gives you the same thing, right? But then to the left of the origin, you're actually treating it as if you took -1 times the negative value of x. So you can actually drop the absolute value sign altogether. But then what do we do at the origin for finding its derivative? Hang on to that thought, I'll get to that later. I want to go back now to the graph, the same V graph that you saw before, but this time I'm color coding it and using the parts of the piecewise function so it's visually more clear on how we can actually find the derivative of this guy. So what I'm going to do for this is I'm going to take the derivative of each separate part by itself, and for the function -x, we know it's clear that it has a negative slope of 1, right? So -1 is that derivative, and then on the right-hand side, f of x equals x, that derivative is a positive 1. So already we're seeing that depending on the value of x, your derivative clearly is not going to be the constant 1, but it could either be a -1 or a 1. But then now what are we doing here at the origin? Because here at the origin we have this cusp, right? Do we even have a derivative here? Go back to your definition of a formal derivative using the idea of limits. Here's the problem. If you were a little ant walking on this hill, either to the left or to the right, the instantaneous rate of change is unclear because it really depends on if you started walking towards the left or towards the right. So in other words, the left-hand limit and the right-hand limit for finding the derivative at the origin is going to be different depending on which way you're walking, so to speak. So even though the absolute value function here is continuous everywhere, believe it or not, the derivative at the origin does not exist.